Hi there, it's Mr. Alexander, and I want to talk to you about solving logarithms again. What I'm about to show you is what we did in class on Friday, April 17th, and Monday, April the 20th. So let's get right into it. Whenever you've got a log of the same base on either side of an equal sign, you can essentially ignore the logarithms to solve for x. If we're trying to get the x by itself, and you see two logs, same base, they're essentially going to cancel each other out. So what that means is we can just write this as 3x minus 2 equals x plus 18. And from here we're just solving the way we normally do. Minus x plus 2 plus 2. And so that gives me 2x equals 20, or x equals 10, which is the solution here. Now, one little caveat is you'll want to plug this 10 back in up here and make sure that it doesn't spit out a negative number. So 3 times 10 is 30, minus 2 is 28, so that's positive. 10 plus 18 is 28, so that's positive as well. As long as these numbers inside the parentheses are positive, you're in good shape. If, however, you find a number that causes you to have a negative inside the parentheses, then it's not a solution, because you can never take the logarithm of a negative number. Let me show you another one. Let's talk about log base 3 of 73 plus x equals log base 3 16 plus 2 log base 3 of 2. Now to solve this, what we just talked about in the last problem, when you can ignore the logs, that only works if there's one logarithm on both sides. There's two over here, but I can combine them and make them into one logarithm. So I'm not going to mess with this side. I want to keep that log base 3 of 73 plus x. And on this side, I want to combine them. But I can do that only if there's two logs with nothing in front of them. On this one, there's a 2 in the front. But if I move this 2 up over here in the exponent, now I can combine them. I can make them log base 3 of, let's see, this is 16 and 2 squared. So it's going to be 16 times 2 squared. Which of course is just 16 times 4. And now I've got two logs with the same base, and I can set them equal to each other. So I've got 73 plus x equals 64. And to get the x by itself, you're going to want to subtract 73 from both sides, leaving you with x equals negative 9. Now, even though it's negative, it's still going to be okay, because when we plug that back up in here, 73 minus 9 is just 64. So that's a positive number. It's not negative, so it's okay. I want to show you two more. Log base 4 of x plus 4 plus log base 4 of 5 equals log base 4 of 3x minus 2. So to solve this one for x, first we're going to want to combine these. And since there's a plus sign, we can combine them by way of multiplication. So that's going to be 5 times x plus 4, or 5x plus 20. It's 5 times x is 5x, 5 times 4 is 20, equals log base 4 of 3x minus 2. Now that the bases are the same, I can go ahead and ignore the logarithms and set the 5x plus 20 equal to 3x minus 2. And at this point, we'll do minus 3x, minus 3x, minus 20, minus 20, to get 2x equals negative 22, or x equals negative 11. Now here, on this one, when we plug that x back up here, negative 11 plus 4 is negative 7. So this cannot be the solution, because we can never take the logarithm of a negative number. So this one, in fact, is no solution. So that's why it's going to be important to plug that x back into the original problem to make sure that you didn't find a solution that's going to not be calculable. Never can take a logarithm of a negative number, so be careful. One last thing I want to show you. We've got 1/2 equals log base 4 of x plus 10 divided by x plus 8. Now, on this one, you're going to want to use your rules for equations. So remember that y equals b to the x. That's how you write the exponential equation. But if you have a logarithm, x equals log base b of y. So I want to rewrite this logarithm equation as an exponential. So the y in this case is the, well, I usually start with the base. So the base is 4. And we're going to raise that to the 1/2 power. And that equals x plus 10 divided by x plus 8. This looks like something I can solve, because 4 to the 1/2 power, that's just the same as saying the square root of 4, which of course is 2. And all of that equals x plus 10 over x plus 8. Now to get the x by itself, multiply both sides by x plus 8. Of course, they're going to cancel out on this side, and you're going to have 2x plus 16 equals x plus 10 remaining. Subtract the x, subtract 16, subtract 16. We're going to end up with x equals negative 6. Now, is that negative 6 okay? Negative 6 plus 10 is 4. Negative 6 plus 8 is 2. Those are positive numbers. We're not taking the logarithm of a negative. This is the right answer. X equals negative 6. Okay, thank you for watching. Hope it was helpful. Good luck.